This is Mr. Ashton going through the Mathematics Numeracy paper, Unit 2, so calculator is allowed, and it is the intermediate tier from the November or the autumn of 2016. Okay then, so over the page we've got the formula list and then on to the first question. Okay, so the first question says, the travel graph below shows the journey Gareth made yesterday. Now the key thing to notice on the y-axis is that it's measuring his distance from home in kilometres. It then says in the first question, it says, how far away from home was Gareth at 1500 hours, which is 3 p.m. So there's 2, there's 4, so 3 p.m. in 24 hour 15 would be there. So how far was he away from home? At this point here would be 6 kilometres. So the answer there would be 6. And then says, at what time did Gareth arrive back at home? Circle your answer. So we're looking for where his distance from home is 0. So he starts off at 12 and he gets back here. Now, to work out that time there, you could either try and work out the scale here, but even easier in my book would be to say that 1900 must come in the middle of 1800 and 2000. And this is in the middle of those two, so it would be 1930. 7:30. Okay. And then the final question here, let me just move the camera slightly. There we go. Says sometime after 5 p.m. So we're interested after 5 p.m. So we're interested from here onwards. So the only bit of the graph that I'm looking at. It says Gareth headed to the supermarket. The supermarket was closed when he got there, so he headed straight back home. So he gets somewhere and leaves. So here he's the same distance from home. He then gets further away from home and then he turns back to come home because he's getting closer to home. So it must be that point there. So that point is bang in the middle between 1900 and 1600, so it must be 1630. It then says, Gareth did not stop for the whole time between 3 p.m. and 3:30. So let's have a look, see where that is on the graph here. Okay, now interestingly, looking at that bit of the graph there, I would have assumed he did just stop and he stayed the same distance away from home. And the reason why I would have thought that is because his distance from home doesn't get any further than 6 kilometres. But it says, what could the travel graph tell you about his journey between these times? So I'm going to say that he stayed the same distance from his home. Okay, same distance from his home. Okay then, over the page, on to question 2. It says 36,000 people took part in a survey to find their favourite type of TV programme. You just focus on that a bit better so we can see it a bit clearer. It then says the pie chart shows the results. It says how many people chose drama as their favourite type of TV programme. So drama is what we've been asked to find in the question. Here's that piece of the pie chart. You need to have an angle measure. I have a 360 one, you might have a 180 one. It shouldn't matter for this part of the question. Where the crosshair is, you make sure you get the middle of the pie chart there and get 0 firmly on that line. And I can see if I move that measure, which I don't actually like that being there anyway, I can see that it is perfectly on the 100 line. Okay, I can see that line hits my 100-degree angle. So I now know that's 100 degrees. Now, in terms of if I want to work out how many people are in that piece of the pie chart, I do the degrees that we've measured out of the degrees in total in a pie chart, should be 360, so it's a circle, and it times by the number of people taking part. So 100 over 360 times by 36,000, and that goes into my calculator as it looks there. So 100 over 360 times by 36,000 comes to 10,000 people. Okay. The next question says how many people chose sport. So we're looking for sport, and again, we're going to have to go and measure that angle. How many more people, that's an important word I've missed there, how many more people chose sport rather than the news? Okay, so we need to go and find out what both of those angles are, find out how many people are in each, and then find out how many more people chose sport by subtracting those two answers. So measuring that angle, we put 0 on the new line, crosshair goes where it was before. Okay, I can see that is measuring dead in between 110 and 120 on my pie chart, or my angle measure, sorry. So that's 115 degrees. If coincidentally you're finding it hard to measure, what you can do is you can extend the lines out of the pie chart like this, and then you definitely can see that it goes beyond that 115 there. Okay, so 115 there. Let's measure the news. So I measure that angle there, I make that 55 degrees. One thing to note, you are allowed to be a couple degrees out from what I'm saying. You're allowed to be plus or minus 2, so you could have said 53, 54, 55, 56 or 57 there, as long as you've measured that yourself. So now let's work out what the sport was. Sport was 115 out of 360 times by 36,000. Find out what that is in a second. The news was 55 out of 360 times by 36,000. We'll find out what that is, and then we'll take them away. So 115 out of 360 times by 36,000 is 11,500. Who said sport? And then if I just use the calculator and delete the 1, put in 55, find out that's 5,500. So how many more people would be 11,500? Take away 5,500, which is 6,000 more people. Okay then, over the page, it then says twice as many women as men chose talent shows as their favourite type of TV programme. So we need to go and work out how many people said talent shows. So talent shows was the only angle they gave us, which is 90 degrees. So we know that should be 90 out of 360, which is a quarter of 36,000. So that must be 9,000 people. So job number 1, we find out how many people said talent programmes. The next thing we now need to look at is what they've told us, that that twice as many women as men chose talent shows. Okay, so the way I'm going to do this is I'm going to say men are going to be a box that's X. Okay, now women must have been twice as many, so we'd have one box of X and another box of X. Okay, and all together it's got to make 9,000. So how many X's have we got there all together? 3x, that would be equal to 9,000. So x would be equal to 9,000 divided by 3. So x would be equal to 3,000. Now that's men. Women were 2 of the x's, so women would be 2 times by 3,000, which is 6,000. Okay? Then says below, 1,000 people are asked, should the news programme include details of the weather, yes or no? 70% of the people answered yes. A pie chart is to be drawn to represent this in the question. What size should the angle be? Well, we know it's 70%, and it wants us to put that into a pie chart, which has 360 degrees in it. So we want to find 70% of 360. Percent means out of 100. So I'm going to do 70 out of 100, and then you times it by the number in question. So 70 out of 100 times by 360 tells you that the angle should be 252 degrees. Okay then, over the page, it says, Loretta is paid in euros. She is checking her tax bill for last year. The tax rates last year were as follows. No tax on the first 3,500 euros of earnings. Earnings in excess of 3,500 and up to 10,500 taxed at 25%. And earnings above 10,500 taxed at a rate of 35%. Last year, Loretta's total earnings before tax were 34,500 euros. How much tax did she pay? Now, I always find it's useful to draw a block to demonstrate what's going on in this sort of question. So this block is going to represent all of Loretta's money, okay? So all I've done so far here is draw a rectangle, and that represents 34,500 euros, okay? Now here is 0 euros. She hasn't had any of her euros at all, and here is the full amount of euros, so 34,500 euros, okay? Now, working through the question here, it says no tax is to be paid on the first 3,500. So 3,500 would be roughly here, 3,500 euros, and that is at 0% tax. So no tax on that first 3,500. The next thing that we're told is that we have an excess of 3,500 to 10,500 is taxed at 25%. So this bit of money from 3,500 to about here, 10,500, is taxed at 25%. Should have written that 0% there, really. And what we need to do is work out how much of the bar that much represents. So to work that out, I want to do 10,500 take away the 3,500. And that tells me this is 7,000 euros here. So we're going to have to work out 25% of 7,000 euros at some point. I'm not going to do it now, I'm going to work out the rest. And then it tells me that earnings above 10,500 are taxed at 35%. So this bit here, we need to work out how much money she's going to be taxed at 35%, okay, which is quite a lot of the bar. So it's going to be 35% of the difference between 34,500 take away 10,500, which is 24,000 euros. Okay, so same as before, percent means out of 100, so 25 out of 100 times by 7,000 is 1750, and 35%, so 35 out of 100 times by 24,000 is 8,400 euros. So her total tax would be the two of those combined. So adding on the 1750 onto that gives me 10,500 euros. Oh no, that's light. Misread my calculator display there. Is 10,150 euros. Okay. Okay, then have a quick read of the question for number 4. I'll start going through it in a moment. Okay, then it says Ewan is going on holiday to India. He has saved £450 to exchange for Indian rupees. The exchange rate on the internet last week was £1 is equal to 99.4 rupees. Now, to change pounds to rupees, we would times by that number, and to change that back from being rupees into pounds, we would divide by that number. We're then asked, had Ewan been going on holiday last week, how many rupees could he have bought? So he has £450. We want to use that exchange rate, so changing the pounds to rupees. So £450 multiplied by the rupees would tell me how many that he could get. That's why all exchange rates was written as 1 equals, because we just times by it, it makes the calculation a bit easier. So that tells me that he could have afforded 44,730 rupees last week. Okay, we're told that Ewan exchanges his money on arrival in India. The exchange rate has changed. It's now £1 is equal to 99.72, so only ever so slightly, but it has changed. We're then told that the bureau only has 500 rupee notes, so we can only get them in multiples of 500. So we get a 500, a 1,000, a 1,500, a 2,000, and so on, okay? So that's what that's telling me. Ewan wants to buy as many rupees as possible with his £450 saving. How much of his £450 will Ewan spend buying rupees? Give your answer correct in the nearest penny. So he has £450 that he takes with him to India. We times it by the new exchange rate. So timesing that 450 by, oh, hang on, have I done the last one? Yeah, the last one's fine. So we do 450 times by 99.72. And that is equal to slightly more rupees. It's equal to 44,874 rupees. But the problem is they only have 500 notes. So we're thinking of what number you could actually use or get up to with 500 notes. So we know we could get in the thousands, no problem. So 44,000 we could get there, no issue at all. Then 44,500, yes, we could get to that. But then 45,000 would be the next one. Now, we can't afford 45,000 rupees, and they don't just give me extra money for the kindness of their heart. So we can afford 44,500 rupees, I'll say, due to 500 notes. You don't need to write that down, though. It's not a quality of communication question. So then we need to change that from being rupees back to pounds to know how much he'll be charged. So we want to do 44,500 divided by this exchange rate, so divided by 99.72. and that comes to slightly less, as you'd expect. So he'll pay £446.25 to 2 decimal places. Okay then, over the page, we are assessed this time on the quality of our organisation, communication, accuracy in our writing, okay? We don't need to write an essay for this, but we do need to show any pound signs, any weight signs if that was appropriate. And just have little arrows just explaining why you've done calculations. Don't have any calculations, you just put into calculator, write them all down onto your paper. Okay, it says, rail card for 16 to 25-year-olds, £30 for a year, get a third off all your rail travel. Neris and Aleri are sisters. Neris is 22 years old, so she qualifies because you have to be between 16 and 25, and Aleri is 27, so she can't buy this. The two sisters live in Holyhead, in the north of Wales. Their aunt lives in Milford Haven, so in the southwest of Wales. They travel by train to visit their aunt 3 times a year. Neris buys a 16 to 25 rail card for these journeys. They buy a single ticket for each journey. The cost of a single rail ticket from Holyhead to Milford is £84.50. The journey home from Milford Haven also costs £84.50 per ticket. In a year, how much less does Neris pay than Aleri for the journeys to Milford Haven and back? You must show you're working. Okay, so there's some really important things here. They go 3 times a year. They cost £85.50 for a single ticket and then £85 for the return journey, and they do that 3 times a year. Okay, so what we need to do is to work out the cost of what it would be just ordinarily. Then we'll work out the cost reduction that we get by having a third off. But don't forget that this also costs £30 a year to purchase, okay? So let's start off with the normal costs. So I'm going to put here a little heading saying normal cost, so it's nice and clear what I'm doing. We have £84.50. As I said, make sure you put your pound signs in these type of questions, and the journey back, so £84.50. Add those two together, £84.50, add £84.50, comes to £169. Okay, so I'm going to say cost for one return journey. I'm then going to say, so 3 journeys, we could have written the number 3 there, 3 journeys equals £169 times by 3. So we're going to times that number by 3, hopefully not get a syntax error, and get £507 for the normal cost. Okay, so that's the normal cost. That's how much her older sister, has to pay. So now we're going to work out discount for Neris. Okay, so we want to find out a third of 507, which is the same as doing 507 divided by 3. So 507 divided by 3 equals £169. So that is the discount for Neris. So we now want to do £507, take away 169, 507 take away 169. So the cost, so I shouldn't say equals there, take away 507 take away 169. So it would cost Neris £338 cost. So now we have to work out Neris's total cost, which would be the £338 plus the £30 for rail card. So I'll just point and say that. Cost for rail card, which would equal £368 for Neris's total cost. Okay, now just double check that we've answered what it says in the question. It says, in a year, how much less does Neris pay than Aleri? How much less does Neris pay than Aleri? So we haven't answered the question. We've worked out what her sister has to pay. So her sister pays the normal cost. So if I say normal cost, I might say, that's supposed to be an arrow, not a very good one. This is Aleri's price. Okay, so then to work out the difference, it would be 507, take away the 368. So it's a £139 difference. Okay? We're then told in part B, Cristiano is 22 years old. He sometimes travels from Rhyl to Llandudno Junction by train. The cost of a single ticket from Rhyl to Llandudno Junction is £7.80. Neris advises Cristiano to buy a rail card. Cristiano says it's not worth paying £30 for the rail card. Now, he's not doing any big journeys, so a third off that isn't actually going to be very much. It then says, how many times in a year would Cristiano have to travel to make it worth his while for him to buy a rail card? So his cost that he normally pays is £7.80, so he'd get a third off that. So if we work out what 1/3 of £7.80 is, now that would be again doing £7.80 divided by 3. Which is £2.60. That's how much you'd save per journey. Saved per journey. To work out the total number of journeys that he would need to save, he'd do the £30 you'd have to pay, divided by the £2.60. So 30 divided by £2.60 comes to 11.5384, blah, blah, blah. Okay? Now, this answer here tells you that it's 11 and a bit journeys that he needs to do in order to get that money back. So, 12 journeys would need to be in total. He doesn't quite make it back by doing 11 journeys. For instance, 11 times by £2.60 is £28.60. So, he's still short the 30 quid. So, 12 journeys needed. Okay, then question 10. It says the total area of all woodlands in Wales is 303,000 hectares. Individual woodlands that have an area of 2,000 hectares or more make up 76% of the total area of woodlands in Wales. Complete the following statement. The woodlands with areas of less than 2,000 hectares in Wales cover a total area of how many hectares? Now, the one thing to notice here is they put this in bold. It says less than 2,000 hectares. And if I come up here, it says the area of 2,000 hectares or more make up 76%. Well, in that case then, the areas that make up less than that must be 100%, take away the 76%, which is 24%. So it's going to be 24% times by 303,000 to work out the area of those woodlands. Okay, so 24 out of 100 times by 303,000. Okay, so 72720. Okay, then the next question says it says the price of software changes each year. The price has increased by 6% per annum meaning per year, for each of the last 5 years. Before this, the price had decreased by 2% per annum. 7 years ago, the price of softwood was £34 per metre cubed. Calculate the current price. Now, to do this sort of question quickly and efficiently, if we're working with numbers like 7 and 5, so there by definition 2 going in here, we need to know multipliers, okay? Now, multipliers to work out increases by percentages and decreases by percentages are quite easy to work out, but we've got to know what to look for. We're looking there at an increase of 6%, so we need to work out that multiplier, and a decrease of 2%. An increase of 6% has a multiplier of the following. You do 100% plus, because it's an increase, 6%. That is 106%, which would be, as a decimal, 106 divided by 100, which is 1.06. Okay? Now, similarly, a decrease you work out in the same manner. Say a decrease of 2% would be 100%, but a decrease means that we subtract the 2%. 100% take away 2% is 98%. 98% means 98 out of 100. So as a decimal, it'd be 0.98. Okay, so let me just highlight a few important bits there. Decrease means that we take away from 100, whereas an increase means that we add it on to 100. You always start off with 100 and you work out whether you're adding or taking away. Now, we just need to retrace our steps and work out what's happening. 7 years ago, it was £34 per metre cubed. So we do £34 multiplied by, and it says the price has increased for the last 5 years, but before that it decreased. So we do the decrease of times by 0.98 to the power of 2, because it decreased for 2 years. If it's 7 in total, and that's accounted for 5 years. And then it went up by 6%, so times by 1.06 to the power of 5, because it's 5 years. All of that goes into the calculator, and that will tell us what the answer is. So 34 times by 0.98 squared times by 1.06 to the power of 5 comes out at £43.70 to 2 decimal places. Okay, then have a quick read of the question. I'll start to go through it in one moment. Okay, it says the head teacher of Uscall Gwyn investigates building a new bike shed. Bike sheds are built on a rectangular base with width x meters and length y meters. Which is the current expression, or which is the correct expression for the perimeter of the bike shed? Okay, so the best advice I could give you is to draw out a rectangle that could be the base of the bike shed. We know that its width is x and its length is y. That means this is also x and this is also y. If I was to work out the perimeter, it would be the journey around this rectangle. So we would add those as we go along to get 2x, add 2y. So it's that answer there. It then says the head teacher is given the following formula to work out the number of bikes, B, that can be stored in a bike shed that has a base of x and a length of y. The formula is as follows. B equals 6xy over 5. According to the formula, how many bikes could be stored into a bike shed with a width of 5 meters? So x is equal to 5 and a length of 8 meters. So y is equal to 8. So what we do is we substitute those numbers into this formula. Touching means timesing. The best way to do it is just change the letter for open brackets and just chuck it into your calculator as it looks there. Okay, so I press the fraction button, brackets 5, brackets 8 over 5, and that tells the answer is 48. It then says a bike shed x meters wide and y meters long can hold B bikes. According to the details, the head teacher has been given what is the formula for calculating out the length y. Basically, what they're asking me to do is rearrange that formula to get y by itself. So the first thing I'm going to do is get rid of this thing that's this expression is being all divided by 5. I'm going to times both sides by 5. So this expression I'm now working on over here, and I've literally just times both sides by 5 to get 5b, and that divided by 5 has now been cancelled out here. Now this 6x is timesing by the y, and I want to get the y by itself. Okay, to get the y by itself, I want to get rid of anything that's touching it, which means it's timesing it. So I want to divide both sides by 6x. Dividing both sides by 6x will be 5b divided by 6x, and the 6x here will cancel, leaving me with 5b over 6x is equal to y, or y equals 5b over 6x, and I can see it's this one here. Part B. It says the head teacher decides to place signs around the school site to stop pupils using their bikes on grassed areas. He introduced a new sign to pupils in the newsletter. The size of the newsletter is 2.6 centimetres by 2.1 centimetres. It then says a mathematically similar sign. Now that's the key bit here. Similar means they have a common scale factor. So we look for what we call a corresponding length that is the same. Now because this is a straight line, we should know the following formula, that the small length times by my scale factor would give me the big length. Okay, so the small length is 2.1, times it by the scale factor gives me 33.6. So to work out what the scale factor is, I want to divide both sides by 2.1. So I do 33.6 divided by 2.1. So the scale factor is 16. This side has been made 16 times bigger. If I was working backwards, I would divide by 16. It would tell me other things there. Now I've been asked to work out how wide is this sign. So how wide is it? So I look at that length there. So the small one to come to the bigger sign, I would do 2.6 times by 16. So that is 41.6 centimetres. Okay then, over the page it says a wire window guard has been made. The length of each of these small wire squares is 3.3 centimetres. Then it says Hlinos considers the length of the diagonal of each small square. So this diagonal here would be what we call the hypotenuse because it's opposite the right angle. I know two sides of it as well. I know that side and that side, they're both 3.3. Then says the height of a window guard is equal to 3.5 diagonals of the square. So effectively this would be 3.5 times by whatever that diagonal is there. And the width is 11 diagonals. So this would be 11 times by whatever the diagonal is to work out what that is. Okay. Over the page then, it says calculate the length of the diagonal. So it wants me to work out what this length here is. Okay, now it's a right angle triangle. I know two sides. I want to know a third side. That should be telling you to use Pythagoras' theorem. So Pythagoras' theorem states a squared plus b squared, and I always say is equal to h squared, h for hypotenuse. So that's going to be 3.3 squared plus 3.3 squared is equal to h squared. Now, this bit is going purely into my calculator. So 3.3 squared plus 3.3 squared is, SD it to get 21.78 is equal to h squared. Now I don't want to know what h squared is, I want to just know what h is. So to get rid of that squared, I'm going to square root both sides. So square rooting 21.78, well, let me make sure it's in my calculator correctly, 21.78, I get the answer 4.6669047 blah blah blah. It says in the question, can you find that correct to one decimal place? So to one decimal place, that would be 4.7 to one decimal place. Okay. Now, in the question below, it says calculate the area of the window guard. Now we know this is 9.5 lots of the diagonal, and we know this is 11 lots of the diagonal. So to work out the length and the width of what that is, and then times them together to work out what the area is. Okay. So we know that the window guard is 4.7. So if we do, I'm going to just draw that here so we can see it nice and clearly on the sheet as well. 9.5 times by 4.7 gives me an answer of 44.65 centimetres. That's how wide that is there. And then 11 times by 4.7 gives me a width of 51.7 centimetres. So that's how long it is there. So to work out the area, I just want to do the length times by the width. So I want to do 44.65 times by 51.7. Now the one thing I will say, this answer is not hugely accurate because I'm using the rounded answer. It is acceptable, I checked the mark scheme, but I will show you how you can do that the other way as well. So 51.7, so 2,308.4 centimetres squared to one decimal place. Now to get a more accurate answer, if I go back to this answer here, 3.3 squared plus 3.3 squared, and then I square root that answer, I have this unrounded one here. Now what they really wanted to see you do to get that nice and accurate was do 9.5 times by that answer, and then we're multiplying by this width here, so it would be 11 times by that answer again, and this would give an answer of 20, I'm going to say here, I'll just write here more accurate, is 2,276.01 centimetres squared. That's the one that they were after, but they did give the mark for this one as well, so both of those got the marks, okay? But that's about being confident in using the rounds button in your calculator. Okay then, over to the other page then, question 16. It says, Gwenda enjoys road running. She keeps a record of her run each day this week. So we have all of these details here. It then says, last week her average speed was 9.6 kilometres per hour. Calculate Gwenda's percentage improvement in her average speed from last week to this week. You must show all of your working. So to work out that, I need to work out what her new speed is this week. So to work that out, I need to work out the total distance travelled there. And I need to work out the total time that took. and I'll now know what her new speed was. So I'm going to say total distance is going to be 4.6 plus 5.4 plus blah, 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 up until 3.4. Okay, so adding all those together, we get 4.6 plus 5.4, 2.2 plus 6.2, 7.2 plus 2.2 plus 3.4. Okay, so that is 31.2 kilometres travelled. And then we're going to work out the total distance, not the total distance, we've just done that, the total time, which would be 26 minutes plus 31 minutes plus all the way up until 22 minutes. So 26 plus 31 plus 12 plus 35 plus 40 plus 14 plus 22 is equal to 180 minutes. Okay, now one thing to spot here. This was given in kilometres per hour. This is in minutes. We need to turn it into hours. Luckily for us, that's quite a nice number. That dividing that by 60, we should know that's 3 hours. Okay, you see, I almost wrote down the correct answer there too early. So to work out her speed is equal to distance over time. If in doubt, use your triangle. Speed equals distance over time. So the speed is equal to 31.2. That did say, or should have said, 31.2 kilometres over 3 hours, which is then equal to 10.4 kilometres per hour. So km/h, kilometres per hour. Have we answered the question? It asks to find out what a percentage improvement is. Okay, so to do that, you need to know the following formula. It's the difference divided by the original times by 100. Okay, so the difference between 10.4 kilometers per hour and 9.6 kilometers an hour. So you can just literally do that by writing in 10.4 take away 9.6 over what it was originally, so over 9.6 times by 100. Okay, so fraction button, 10.4 take away 9.6 over 9.6. Oh, didn't want to press that. Over to the side times by 100 is equal to 8.3 reoccurring. Okay, absolutely fine to put a dot on the top of that, that'll be fine. You could round it to 1 decimal place if you wanted to. Okay then, question B, have a quick read of the question. I'll start to go through it now. Okay then. We're asked to go and work out what the we're told the diagram shows a cross-section of one part of her run. Calculate the angle of elevation of the road. So basically, how much does the road go up by? So we're looking at this angle here. That's the angle it's after. Now you'll notice we have a right angle triangle. I want to find this angle here, which I'm going to call X. If that's the angle I'm looking for, this is opposite the angle and I know it. And this is adjacent to the angle and I know it. So I'm going to underline both of those. I'm now going to write out SOHCAHTOA because it's a right angle triangle. I'm going to cross out anything with an O or an A in it because I know both of those ones. So O and A, O and A. Because TOA has both letters crossed out, I write out what that tells me as a formula. So tan X, is equal to the opposite side, so 200 divided by the adjacent side, 1,600. To get X by itself, I do the inverse of tan. So I do inverse tan of 200 over 1,600, and then I will put that into my calculator. So I press Shift and tan to get inverse tan, 200 over 1,600, bracket at the end, tells me it's 7.1 to 1 decimal place. So 7.1 degrees to 1 decimal place. We're then told in part C that Gwenda runs another section of uneven road from A to B. The rise in the section of the road is 300 metres, as seen there. The angle of elevation is 10 degrees, so it's gone up 10 degrees here. Calculate an estimate for how far Gwenda has run. Now, she runs here. This is the hypotenuse, effectively, of this triangle. So I'm going to underline that because I want to find it. This is opposite the 10 degrees, and I have it, so I'm going to underline it. The edge, I don't know it, I'm not asked to find it, so I'm not interested in it. Okay, I'm just going to put a cross through it. Again, I'm going to write out SOHCAHTOA. But this time I'm going to cross off anything with an O in it because I have it, and H in it because I want to find it. So O and H, I can see that I've already double crossed out. So if I carried on, I just crossed out those ones. So that tells me sine angle, so sine of 10 is equal to the opposite side, so 300 divided by the hypotenuse. Now I want to find the hypotenuse, so I'm going to times both sides by the hypotenuse to bring sine 10 times in by the hypotenuse to cancel out there, would leave me with 300. And then I'm going to divide both sides by sine 10. So the hypotenuse is equal to 300 divided by sine of 10. So I'll find out the hypotenuse over here. I'm giving you much room for this. 300 over sine 10 is 1,727.6 meters to one decimal place. Okay, now my assumption, when it says what's your assumption, my assumption is that we've just gone in a straight line from here to here. Now that is always the shortest distance. Going between 2 points in a straight line is the shortest distance. My real distance is I've gone up a little bit, down a little bit, and it's been a bit wavy. So my assumption is that it's been a flat road. Okay. In terms of what impact my assumption will have, the actual distance will be further. Okay, so I'm going to say the actual distance will be further. Okay. Over the page, it says Rodri has carried out an experiment to measure the diameters of 20 spherical dust particles. Here are his results. We're asked to calculate the mean for each diameter. Now, to do that, we need to create two new columns. One called the midpoint, and the other one is going to be called the midpoint times by the frequency. Now, in terms of what's in the middle of 1 and 2, nice and easy, 1.5, but don't just start blindly filling those in. Check what is in the middle of 2 and 4, which would be 3, in the middle of 4 and 5, which would be 4.5, and in the middle of 5 and 9. Now, if ever in doubt, do 5, add 9, so the first add the last, and divide that by 2, and it will tell you what's in the middle. I would like you to cross out underneath that so you don't accidentally add up that column. You do add up 2 of these columns, but it's never the midpoint column. You add up the frequency column, although we are told that there's 20 there, so we know what that is. And then we would times together 1.5 times 2 to get 3, 3 times by 6 to get 18, 4.5 times 8, so 4.5 times 8 is 36, and then 7 times by 4, which we knew is 28. We now work out the total of that column, so 28, add 36, add 18, that's not the clearest 18 I've ever drawn, 18, add 3, which comes to 85. To work out the mean is equal to the total of the midpoint times frequency column divided by the total frequency column. 85 divided by 20 is equal to 4.25, whatever it was measured in microns. Okay, now the next question is quite sneaky. Okay, have a read of it. Let's try and make sure we get our heads around what it's saying. It says Rodri measures the diameters of another 25 dust particles. Now that's the key word here. He's already done 20, now he does another 25. He is told that the ratio of the dust particles with diameters of less than 4 microns, to those with diameters of greater than or equal to 4 microns is, and then we have a ratio of 7 to 8. Okay. It then says he finds this fact is true when he considers all 45 dust particles. So all 45 dust particles are these guys here, the 25 there, and the 20 from up there. Okay? It's those guys and those guys. It then says how many of the extra 25 dust particles have a diameter of less than 4 microns. Okay, so we're interested in less than 4 microns. The extra 25 dust particles have a diameter of less than 4 microns. Okay, so we're interested in here, this is less than 4, so this category. So the 2 there, and here, these are less than 4 as well. So there's 8 there from the first 20 collected. Now we know that this ratio works for all 45. So what we're going to do is do 7 add 8 to get 15 parts in total. And then we're going to do the 45 dust particles that you collect divided by 15 to find that one part of the ratio is equal to 3, and I'm going to say for 1 part. Now it said 7 to 8, and that was for 4, less than 4 to greater than 4. So the less than 4, which is the bit we're looking for, is the first bit, which is 7. Okay, so we're going to do 7 times by 3, which equals 21 particles with a diameter less than 4 microns. Okay, now we've already accounted for 2 and 6, so that's 8 in total, and there's 21 particles in the entire sample. So 21 take away 8 tells me that there must be 13 extra in next 25 dust particles. Okay, so more than half of the next set. Okay then, we are on to the very last question. So it's been a tricky paper. There's been some nasty questions in this, and this finishes off hard as well. It says, Rodri studies the cylindrical cell under his microscope. Now, that's the key word there. Cylindrical means a cylinder. So I'm going to draw what a cylinder looks like. It looks, in big, zoomed-in version, something like that, okay? That's what that first bit tells me. You need to draw these things to get your head around what they're asking you. We're told that the height of the cell, so its height, is 2 microns. Okay, done. Height, 2 microns, there, 2 microns. We're then told that the circumference is 5 microns, so that's this distance around here. Okay, so the distance around here is 5 microns. It's then asked me to work out or to calculate the volume of the cell. Okay, correct to one significant figure. Now, to do the volume of a cylinder, the formula we need to use is pi r squared, which is the area of the circle, times by how long it is or how high it is, so times by height. That's the formula that we should know. And the problem is at the moment is we don't know what the radius is, but we do know what the circumference is. So I'm going to use the formula for circumference is equal to 2 pi r to rearrange that and find out what the radius is. So the circumference is 5 macrons. That's equal to 2 pi times by the radius. So to get the radius by itself, I want to get rid of what's touching it, which is the 2 pi. Touching means timesing. So I'm going to divide this side by 2 pi, and I'm going to divide this side by 2 pi. They're going to cancel out, leaving me with just the radius, and that's just going to stay as 5 divided by 2 pi. If I wanted to, I could go and find out what that was on my calculator. I'm doing 5 divided by 2 pi, but you'll notice it's a really long, horrible number. So it's easier for now just to leave it as that, okay? And I'll use it like that in my calculator. So now coming back to that volume formula, I'm going to say volume, V, is equal to pi, the radius squared, so 5 over 2 pi squared, and then times by the height, which is 2. Okay, all of that goes into my calculator. Don't try and cancel anything down. There's no need because of the way we've got that written. So brackets 5 over 2 pi squared, and then brackets 2 tells me that it has a volume of 3.978873577. Now, it did say it wants this rounded to one significant figure. So you can see it's highlighted in green up here. So to one significant figure, you start counting the first non-zero number, which is literally the 3. So to round that would be 4 to one significant figure. Okay, I hope that was useful. If it was, please hit the subscribe button and you'll get access as and when I release any more papers. Thank you very much for watching.